In this video, we are going to solve various problems on viscosity. Those are theoretical. So let us start with this, in which it has been asked in GATE 2001, the SI unit of kinematic viscosity, nu. If you remember this SI unit for kinematic viscosity, so that is meter square per second. If you remember, we have already calculated this. So this is theoretical question. Directly you can answer it. Option A will be correct then. We have to go with option A. Option A is correct. Next, unlike the viscosity of liquids, the viscosity of gases increases with increasing temperature. This is due to. Now see, when we talk about the viscosity, because they have not mentioned specifically whether it is kinematic or dynamic viscosity, so we should focus on dynamic viscosity. Now, the viscosity of gases they are talking about. They are talking about the viscosity of gases increases with increase in temperature. So first you should know that the effect of temperature on viscosity, kinematic viscosity and dynamic viscosity, both you should remember. So if you remember that we have already completed it, that if you increase the temperature, then if you increase the temperature, then dynamic viscosity and kinematic viscosity both. For now we are talking about the effect on gases. So we should know whether it will increase or it will decrease. Remember, if we increase the temperature. So we know that whether dynamic viscosity or kinematic viscosity, they both will actually increase. Remember, they both are going to increase. With increase in temperature, the dynamic viscosity of gas will increase. At the same time, this will also increase. Now, what is the reason behind it? So the reason we can say, uh, the moment we increase the temperature, then what happens? Because of increase in temperature, these are the gaseous molecules. They have mass m and their velocity is v. But the moment you increase the temperature, so that means energy of these molecules will get increased. So that energy increase means this kinetic energy, half mv square will get increased and velocity will also increase. So basically the momentum transfer will get increased because now the particles of gases will move with a higher velocity. So that means we can say it as, what is increased here? The momentum transfer is increased here. So here the viscosity increases due to momentum transfer in the molecules, right? So which is our correct option? Increased momentum transfer in molecules. At the same time, let us have a look on this first option, increased cohesive forces between the molecules. So remember that cohesive forces, they are the reason for viscosity in liquids, not in gases. Momentum transfer value here, it is not going to decrease with increase in temperature, it is going to increase. So this option cannot be correct, this option cannot be correct, this option cannot be correct, and increase in both cohesive forces and momentum transfer. So cohesive forces are not going to increase. Why? Because with the increase in temperature, the molecules will now be at further distance. They will be at, again, distance between them will increase with the increase in temperature, increase in energy. So this cannot be true. So our option will be this, correct option will be B. Now again, Newton's law of viscosity relates. So remember what was Newton's law of viscosity? It was tau is equals to mu du over dy. Simply this was the Newton's law of viscosity, where the value du over dy is known as what we call it? We call it velocity gradient. And this velocity gradient du over dy is equals to d theta over dt, which we know as this value we know as shear strain rate. So now we check the option. First option says velocity gradient and rate of shear strain. So both we are not talking about. This cannot be true because velocity gradient and rate of shear strain both are equal. They are same thing. So this cannot be true. Next, rate of shear deformation and shear stress. Okay. The rate of shear deformation is the right word for this, d theta by dt, which is equals to du over dy. So rate of shear deformation, we can go with this du over dy right hand side and shear stress on left hand side. So this seems to be the correct answer. Option B. Option B seems to be the correct option. Now we will check the other also, that in this case they have written shear deformation and shear stress. So this is not the shear deformation, instead this is the rate of shear deformation. So this cannot be correct. Even this option cannot be correct. And pressure and volumetric strain, no, Newton's law was not about this, so this cannot be the correct option. So correct option, we are left with option B. Next, another problem, which what is the unit of dynamic viscosity of a fluid termed poise equivalent to? So remember that the poise term is CGS unit. Now you should keep this in mind that poise is the unit for dynamic viscosity. Now dynamic viscosity in CGS unit, what we can write? So remember that again, the expression for it was tau is equals to mu, that is dynamic viscosity, du over dy. So mu can be written as tau multiplied by dy over du, which we can write as tau value will be in poise or CGS unit. So in CGS unit, tau can be given as dyne per centimeter square multiply by this dy can be given as centimeter, and this du can be given as centimeter per second. So if you can see here, this centimeter and centimeter, it will get cancelled out. So what we will be left with? We will be left with as our answer that the value of mu is will be equals to this dyne second per centimeter square. So here we can see that the correct option will be dyne second per centimeter square. Option C. Dyne second per centimeter square seems to be the correct option. So we will go with this option. This seems to be correct. Next problem is, that is also previous problem asked in 1998, Engineering Services 1998. In this, Newton's law of viscosity depends on. Now Newton's law of viscosity, again it depends on what? So we will write it again, that Newton's law of viscosity, tau is equals to mu du over dy. So this is the value. Now stress and strain in a fluid, shear stress, pressure and velocity, shear stress and rate of strain, viscosity and shear stress. So what could be the correct possible option for us? So can you think of it? Just take 30 seconds and think about it. What could be the correct possible answer? Obviously, we have already seen that. See, the value this shear stress left hand side and rate of strain or rate of shear strain on right hand side. So this is the correct option. Some of you might wonder that, sir, this is also relating viscosity and shear stress, but viscosity is constant. For Newton's law, viscosity is constant. It will not vary. So the law relates this tau value with shear strain rate du over dy. So that's all in this video. Thank you.